That's recording this session. So most importantly, it's for you to understand the OIS model, the 7 layers, also the TCP/IP protocol suite.
UDP and all that nonsense. Yeah. Wait, I'm on speaker.
Hello?
Hello?
Yeah, I can hear you.
Hi.
Hi, how are you?
I was talking to myself. Sorry.
Okay. Yeah, so I was saying we need to understand the communication basics. Communication basics includes a lot of things. So let me say the syllabus of network technology falls under OIS model, just like the other course you are doing, advanced networks. It's also supposed to be, you need to understand the OIS model. So this one and the other one, they are more the same. Okay, so I'm going to open the OIS model, the overview of the OIS model. So those are the 7 layers that you need to understand, or you can call them 7 layers, or you can call them OIS model. It's all the same. So on the layer 7, we have the application layer. On the layer 6, there's a presentation layer. Layer 5, it's a session layer. Layer 4, it's a transport layer. Layer 3, it's a network layer. Then layer 2, it's a data link layer. Then layer 1, it's a physical layer. So you need to understand the functions of each and every layers, and you shouldn't forget these layers. You should be able to tell me the layers, isn't it? What do you think it's a layer? What do you think? Anyway, can someone tell me all the layers starting from the layer 1 up to the layer 7? Are we together?
Yes.
Okay, any idea? These 7 layers.
No idea.
No idea.
I don't know. I think from what I know is more of the hardware is at the bottom, and as you go on top, that's where it becomes less hardware. For instance, maybe the physical layer at the bottom. That's probably where you have some of your switches, or I would say maybe basic switches and data link, maybe layer 3 switches, network transport. Then you've got your session, presentation, and then lastly on top the application layers.
Anyway, so you have a lot to do. You have to remember these layers. Okay, I'm going to just show you something. OIS model. And if you don't want to forget this OIS model, you say, please do not throw sausages, pizzas away. If you are starting from down going up, if you are decapsulating, I'll explain the decapsulation and the encapsulation. Decapsulating is when you are starting from layer 1 going up. Okay, so P stands for presentation. P stands for presentation. And P, it's a layer 1. Presentation, I mean, it's for a layer 1. Presentation, it's a layer 1. Then do stands for a data link. Do, it's for a data link. Data link, it's a layer 2. Data link, it's a layer 2. Node, it's a network layer. It's a layer 3. It's a layer 3. Then throw, it's a layer 4, which is the transport layer. It is a transport layer. Then sausages, it's for session, which is a layer 5. It's a session, which is a layer 5. Then pizzas presents presentation, which is a layer 6, which is a layer 6. Then away, it's for applications, which is for layer 7. So we have layer 7, which is application. Then you have layer 6. This is a session. Then you have layer 5.
But am I in the right class?
Yes, it's a right class.
Okay.
I mean, this is a presentation. This is a presentation. This is a session. Then layer 4, transport layer.
Transport.
Layer 3, it's a network. Layer 2, data link. Layer 2, it's a data link. Then layer 1, this is a physical layer, isn't it? It's a physical layer. So if you don't want to forget, you know, every time when we are studying, what happens is, for me, I'll come up with my own acronym so that I don't forget certain words or certain meaning. I can come up with my own so that if I mention those acronyms, I'm going to remember exactly what it means. So this one, someone came up with the same to make them remember the OIS model, starting from the physical going up. Okay. Then, if you are starting from the application, if you are starting from up going down, you can say, there's another saying, we say that, we say, all people seems to need data processing. So O is for application, P is for presentation, SIMS it's for session, 2 it's for transport, needs for network, data is for data link, processing it's for physical. Just to make you understand or make you not forget these layers. They are very, very important when you are doing any networking course. So all people seems to need data processing when you are starting from when the communication is starting from application layer, trickling down to the physical layer. And that process, we call it encapsulation. It's called encapsulation. Then from the receiver side, let's say the communication is between the two devices, isn't it? Communication is between the two devices. There is a sender and the receiver. So the sender, this is how the OIS layer looks like. The sender sends via application coming down to the physical layer. Then when the signal is being sent using a transmission medium, it could be a wire, it could be a wireless, then the receiver will receive it from the physical layer, then it starts building up until the application layer. So that process is called a decapsulation. It's called a decapsulation. You are going to understand that in the TCP/IP protocol suite. So the OIS model that you have seen there is for you to understand the functions of each and every layer. For instance, what happens at the application layer? What happens at the presentation layer? What happens at the session layer? What about transport? What are the functions there? Network layer, data link layer, and a physical layer. When we start with, when we are dealing with a physical layer there, you are dealing with something physical that you can touch and see. So it's at this layer where we're going to talk about communication basics. We talk about the transmission medium. We talk about the transmission medium. We can talk about the UTP. UTP stands for what?
Uninterrupted transmission protocol.
No. UTP. UTP stands for unshielded twisted pair. Unshielded twisted pair. Just say unshielded twisted pair. Isn't it? Hello?
Yes, it does.
Yes.
Yeah. Then we have STP. Any idea what STP stands for?
S or H?
STP. There's UTP and STP.
So that would be shielded.
Yeah.
Shielded.
So we have shielded and unshielded. Shielded and unshielded. So you need to understand these types of cabling. So in UTP, under UTP, we have there are actually categories. There are actually categories which are short for CAT. There is a CAT 1, CAT 2, CAT 3, CAT 4, CAT 5, CAT 6. The latest one is a CAT 7. Remember, we are under physical layer. Huh? Under physical layer, we are dealing with anything physical, anything that you can touch, anything that you can see. And even when you are designing a LAN, even when you are setting up a LAN, the first thing is to deal with the physical components. This is where we have trunking, where we are going to lay the cables, the roof, put them in the pipes, dealing with the patch panels, the switches. That is a physical layer. So apart from those, you have to talk about the types of cables. You have to talk about the types of cables. Under UTP, we have CAT 1. UTP stands for unshielded twisted pair cable. So this type of a cable, it looks like, let's forget about CAT 1, category 1. Category 1 is used for telecommunication, and there used to be only 2 wires inside. So this one is for the voice. Then of course CAT 2, this is where data starts from. Should we say a 10 base T, yeah? Then we have CAT 3, CAT 4, but let's start with CAT 5 because most of us we started dealing with the CAT 5. This is advanced cable where you find but I'm not saying it's advanced than there is the 5. After 5, they came up with 5E. Then after 6, they came up with also 6E. So between 7 and 6, there's 6E. So from category 5, this kind of cable comes with 8 wires inside. And these wires are insulated. So we are dealing with colors. There is a striped green and solid green. Anyone to help me with the colors to see if you understand? I'm sure most of you, this is what you do.
Striped green. So there's green.
Yeah.
Hello. So there's green.
Yes.
There's orange,
Yes.
there's blue, and there's brown. So you've got 4 solid and 4 striped.
Yeah, 4 striped. So from this UTP cable, you can come up with a straight through cable and a crossover cable, isn't it? A straight through cable and a crossover cable. A long time ago, devices were not that intelligent, whereby, let's say different devices, which cable are you supposed to use to connect them? Let's say a switch and a router. What are you supposed to use?
Switch and a
And a
router.
router. Is it a straight through or a crossover?
Crossover.
Are you sure?
I'm not sure.
Switch straight through.
Who's saying straight through?
Me.
Are you sure?
I'm saying crossover.
Like no one is sure.
I think it's a crossover.
You haven't have you attended any classes for advanced networks?
Which one? Who, me?
Yes.
Yeah, all of you, advanced networks. Have you started?
I haven't.
Okay.
Not yet.
All right. So a straight through wire cables can be used to connect different devices. A straight through different devices. A straight through. Then a crossover, it's for similar devices, isn't it?
Yes.
Similar devices. But that was an issue a long time ago. Let's say if you got a straight through cable, then you have different devices to communicate. That was a challenge. But nowadays, devices are intelligent. So whatever the cable you have, the device will sense that, okay, this is straight through, this is crossover. So it's not any issue of what type of a cable you are using, okay? So, but for the sake of learning, for the sake of understanding, it's very, very important to remember where technology came from. Okay. Then from there, we have, I don't know where in terms of UTP, which one is the most recent technology? I don't know if there's Cat 8 or there's up to Cat 9. We can still research, or they are still on the lab working on types of cables. So always put this in mind, because this network technology, you'll be using Riverbed or OpNet to design a network. You'll be using Riverbed or OpNet. And the first time when we just commenced with the classes, the first thing that you need to do is to install a Riverbed, okay? To install a Riverbed. I know some you've got a Riverbed, you've got the OpNet on your machines, isn't it?
Yes.
Yeah, so very good. Then we'll be, I'm just sitting in for Dr. Chintu. The timetable is not yet concluded. I don't know which classes I'll be teaching, but we'll start the labs. We'll start working on the labs. For network technology, the labs are conducted in that simulator. A Riverbed is like a simulator, like a packet tracer or GNS. Those who are coming from Cisco background, you understand these things, isn't it?
So if I already have a Cisco packet tracer, do I need the Riverbed?
No, a Riverbed, you need a Riverbed. A Riverbed is something that is more advanced than a packet tracer. Packet tracer can't generate traffic. You can't analyze traffic, but Riverbed you can.
Okay.
Just a minute.
Sorry, how do you spell riverbed?
Hello?
Yeah, I was saying, I'm just trying to inquire on the riverbed. I've never used it. How do you
Yeah.
spell it?
I'm sure a lot of them haven't used Riverbed. No, there will be classes for that, tutorials. We have to show you how to use a Riverbed. So don't worry. And you can just download it from the internet. It's not that easy. So that will be arranged.
Oh, okay. Okay.
Yeah, then
Alright.
after UTP now, we'll talk about also the STP. So STP also, we have to know that there is also fiber. There is a fiber. There is fiber optic. Okay, fiber optic. So these are the, in terms of the wired, this is what we need to concentrate on. But for the riverbed, when you're designing a network, there will be more like talking about 100 base T, 10 base T. You have to know that, okay, 100 base T, this is category 6E. 100 base, 10 base T, maybe this is the cat 5. So you will get there. Okay, we'll get there. Okay. So those falls under physical layer, right? Then they've written physical layer, binary transmission, data link layer, access to medium. Remember I talked about, you need to understand what happens at each and every layer. So layer 7, this is the application layer, which is it's the OS layer that is closest to the user. Of course, as the users, we interact with the application. So the previous semesters or the previous years, when you are doing a project, you have to do a project which is which will mostly cover the lower 3 layers. The application layer, these are the programming projects and so on. And layer 7 provides network services to the user applications. Of course, you can install network applications there. Layer 7 differs from the other layers in that it does not provide services to any other OS layer, but rather only to application outside the OS model. Okay, so the application layer deals with the application outside the OS model. No wonder it's dealing with application. Whatever application you have, just know that they're operating there. Then examples of such applications are spreadsheet programs, word processing programs, bank terminals programs. I mean, there are so many programs. Software programs, we can mention a lot of them. Then the application layer establishes the availability of intended communication partners, synchronizes, establishes agreement on procedures for error recovery and control of data integrity. So don't forget these functions of the application layer. This is what the application layer does. Whereas the, by the way, we are using, this is a free version of Zoom. So every 40 minutes to time out. So when it times out, just log in. I'll be waiting for you already. Okay?
Okay.
Right.
All right.
So presentation layer, it ensures that the information that the application layer of one system sends out is readable by the application layer of another system. So let's say if you send an application using a PDF on the sending side. So this PDF, it's a format. So it has to make, this presentation layer has to make sure that even on the receiver side, the recipient side, it's the same kind of, it's the same form, the same format that is supposed to be used. Because if you use different programs, I'm sure you can even, you understand these things. If you've got, if we have 2 different formats, on the other side, you are unable to open those applications. So examples of those application format we are talking about For example, JPEG, MPEG, ASC, double I. This is a numbering system. HTML, these are just one of the examples. So it's like I've sent you something and you don't have that particular application or that particular program to open what I've sent you. So it will say the format is wrong. So this presentation layer, it just has to make sure that all the both ends, the formats are the same. So the presentation layer translates between multiple data formats by using a common format, provides encryption and compression. What is to encrypt? To encrypting actually is to make sure that the data is scrambled to make sure that a third party is unable to see what is being transmitted. We talk about the internet, the intranet, the extranet. When we define the internet, no one's on the internet. And in the internet, on the internet, you find all sorts of things. You find black hackers, you find hackers, you find white hackers, you find all sorts of people. So if at all you are communicating between this organization and that organization, the intranet, remember where you can secure your network, it's on the intranet or the extranet, because these are private networks. You can create the VPNs. I know you are working, all of you, you understand, you know what a VPN is. VPN, it's a secured, more like a secured pipe between two clients, isn't it? Are we together?
Yes.
Yeah, so
Yes.
encryption is just to make sure that data being transmitted is encrypted to avoid all sorts of things, eavesdropping, to avoid money in the middle. You know, you are going to learn all those things. Then, and also compression of data. You know, data sometimes can be bigger. When you compress it, it will become smaller, easy for transmission. When you start uploading your coursework, they can even tell you that make sure that the coursework doesn't exceed 20 MB, or make sure that the document you are emailing doesn't exceed so much. Supposed to be maybe 20 MB. So how do you do it if it goes beyond? You have to use some compression tools, isn't it? Are we together?
Yes, we are.
Okay.
Learning.
Okay. Then, so presentation layer, make sure that you raise those points if at all you're asked to write those in exam. Yeah, encryption, compression, very important points for presentation layer. Then the types of format, we talk about the types of format also, very important. Then session layer defines how to start. Session layer defines how to start, control, and end conversation called session. Yeah, just like we are having a session. The session we started 18:30, the session ends at 19:30. That's a session, isn't it? Okay.
Yes.
So this includes the control and management of multiple bi-directional messages using dialogue control. It also synchronizes dialogue between two hosts, presentation layer, and manages their data exchange. So it also synchronizes dialogue between two hosts, a receiver and a sender. It synchronizes. In OIS model or in the TCP IP protocol suite, you've got a transport layer that is in charge of transportation of packets. So there you've got protocols like TCP, you've got UDP and SCTP. So STP, when you're using a TCP uses a three-way handshake, meaning that two devices that wish to communicate, they have to, let's say if I want to send something, we have to establish a communication. So by sending an acknowledgement, if I'm about to send, if a station wants to send the packet to the server, it has to ask for the acknowledgement. Then the acknowledgement will come back, then the transmission starts. It's called a three-way handshake. So that's what it means. Session defines how to start, control, end conversations. So this includes the control and management of the mouth bidirectional messages using dialogue control. It also synchronizes dialogue between two host presentation layers and manages their data exchange. So the session layer offers provision for data transfer. For instance, structured query languages and the AppleTalk sessions. We know the SQLs in databases, we know it, and we know the AppleTalk session protocol also. So that is the session. Then we've got the transport layer. This one regulates information flow to ensure end-to-end connectivity between host application reliably and accurately. The transport layer segments data from the sending host system and resembles the data into a data stream on the receiving host system. Then the boundary between the transport layer and the session layer can be thought of as a boundary between application protocol and data flow protocols, whereas the application presentation and session layers are concerned with application issues. Transport layer, it's a layer 4. It uses, it's a layer 4. It uses the 3 protocols. We have UDP, that stands for user datagram. There's TCP, transmission control protocol. There's also SCTP, stream control transmission protocol. So these will be explained in detail, especially in advanced networks. Then layer 4 includes TCP. I've mentioned TCP, transmission control protocol, user datagram, and the third one, which is the most recent, it's called the Stream Control Transmission Protocol, SCTP. SCTP, it's a combination of a UDP and a TCP. Then the network layer, which is the layer 3. Network layer, which is a layer 3, defines end-to-end delivery of packets. By the way, at the network layer, we call them packets. Data link layer are called bits. I mean, physical layer are called bits. The same data link layer frames. Then transport layer, depending on the transmission protocol. This TCP is the one which uses packets. Then UDP uses datagram. Then the STP uses chunks. They are called chunks. They are just called the chunks. We explain more. This is more like an introduction. Then network layer defines logical addressing. At the network layer, the type of addressing that is there, this is where IP addresses are found. IP addresses are considered to be logical. Why are they logical? They're logical because they can be changed at any time. Then we have a data link layer that uses a physical layer. Physical layer uses physical address. I mean, the data link layer uses physical address. Physical address, we are talking about MAC address. MAC address is hardwired to the machine, so it can be changed. We'll talk more about that. Then network layer defines routing works. This is where you are going to learn about the routing protocols. Any idea how many routing protocols do you know?
Is that like OSPF and stuff like that?
Yes, that's the